Welcome back to BSpice. In this session, we'll continue with Ethernet communication, wherein in part two, we'll focus on many aspects like, how to set up an IP address. And we also talk about multicast, unicast, broadcast, and also, how to, set this, what do you call the settings, settings in the sense, um, unmanaged switch, how we can, use an unmanaged switch in a redundant ring, and also the setup and configuration of unmanaged switch and the managed switch. And yeah, so all those details, and also we'll touch upon a bit, web-based management interface, all those aspects. Each components of a web-based management interface also will focus. Okay, let's get on with the session. So, as I said earlier, the setting up of an IP address. Of course, this one you guys all know, but again, just for your refresher. Okay. How to set an IP address? Basically, an IP address is a logical address, right? Assigned by the user of managed switch, okay, and allows the switch to be recognized by the SNMP software, which we discussed in the first session. So address allows the switch to be part of a collision domain. It is similar to a phone number. So a private, collision domain is usually, 192.168.xxx.xxx, right? So that is how it we set up. Then the second question, what is the subnet mask? A method of determining what network devices are local, whether all devices have the same subnet mask. Usually, 255.255.255.0. So if we have all the same subnet mask, they are in the same collision domain. That is the meaning. So to repeat again, subnet mask is the method of determining what network devices are local. Okay. If you have the same subnet mask, then they are in the same collision domain. Then uh, gaining access to the outside computer. How to gain access to the network from an outside computer, right? So, of course, this also right? So, access by an outside computer can be handled in different ways, depending upon the level of security required. So, outside access to a factory floor network can be a dangerous situation, right? Some type of, security, appliance is required, meaning, VPN, right? Virtual private network. So, VPN tunneling is a one method, and security appliance is necessary. So this is how we actually try to access the network from outside the computer. Then UTP and STP cabling. Okay, this one twisted pair cable basically. UTP means unshielded and twisted pair, while STP means shielded twisted pair. Okay. So UTP is what typically installed by phone companies, right, friends? And is of a 10 base T in Ethernet runs over here. Okay. So UTP is graded according to the data carrying ability, meaning level 3, level 4, level 5, like that. And 10 base to Ethernet cable, requires a level 3 cable, at least level 3 cable. And many sites, nowadays install only level 5 actually UTP. So that is the additional information. Then rationale for determining managed and unmanaged switch. Very good question actually. How we are determining the managed and unmanaged switch? If our network has less than 10 devices attached to less than 4 switches, and the possibility of adding more switches and devices is nil, then unmanaged switch will work. IO over Ethernet, an expanding application, and the desire to troubleshoot the network required managed switches. That's how we differ. We differentiate it. Okay. So making the investment upfront in managed switches is always a safe solution. Okay. If the network expands and we have an unmanaged switch, then we may have to replace them and buy managed switches. Okay. So that is the bottom line. Then setup needed for an unmanaged switch. Meaning, do we need a setup for an unmanaged switch? No. So in most cases, unmanaged switches are plug and play devices. Just like the the DC, just like the wire, the DC power to the terminal strip, connect the cable, and yeah, that's it. So unmanaged switch have dip switch setting for each port that can allow if a port loses communication. That is the one. So basically, we don't have to do any setup, right? Then, do we need to connect both power inputs on a switch? No, again. The secondary power input is for the redundant power supply in case of the primary power supply fails. However, in an unmanaged switch, the fault LED will be on actually. So if the secondary power supply is not used, we have to connect jumper wire to the second power input terminal from the first input terminal to what you call extinguish the fault LED in unmanaged switch. Okay. To answer a question, do we need to connect both power input? No. No. Okay. Fiber, FX or copper for the network. So how to choose them? Again, it depends on the distance between the devices. Friends, copper has a limitation about 100 meter. And the distance beyond this require multi-mode fiber, which can transmit up to 2 kilometer, which we have already seen in our fiber optic lesson. And beyond 2 kilometer distance, single mode fiber is required, which can transmit up to 30 kilometer. So it is always good idea to incorporate a mixture of copper and multimode fiber port in our switch selection, so that if we need to connect to a device beyond 2 kilometer, then we will have the port available on the switch. So always buy a switch with few spare ports if possible. It is less expensive than buying another switch for 1 or 2 ports. Okay, so that's it, friends, about this copper and fiber. Then can we use any of the port ring for redundancy? Yes, most of the switches allow us to use any of the ports for the specific media. Some manufacturers have restriction on some port because they are dedicated to be used on the ring redundancy feature. Okay. For example, Ethernet direct managed switches allow any ports to be used for ring redundancy. Okay, so that is the point. Then LED, of course, you know what is LED, but I'm not going to talk about what is LED. I'm going to talk about the color basically. So there are many color. Okay, port LED. In the port LED, yellow means the port is physically connected. Okay, yellow. Okay, friends. Then in the port LED, if a flashing green means the communication is taking place. Okay, and power, PWR, the switch has power. Okay. Then we have a power 1, power 2, right? I'm talking about the LED ports. So power 1 means primary power input that has 24 volt DC. Then power 2 means PWR2 means the secondary power input has 24 volt DC. Then fault, basically fault means the switch has a fault. It may be, the second power input, or maybe the power is not connected. The second power is not connected. Okay, that is how it goes actually, right? Then can we use unmanaged switch in a redundant ring? Yes, we can use, but it is not advisable basically. Each manufacturer uses their proprietary scheme to achieve redundancy, right? And an unmanaged switch, even from the same manufacturer, may not provide the guaranteed performance of the redundant ring. So, for example, if in a redundant ring, the switch that is designated as a redundancy manager sends test packet around the ring, and when they are not received by the redundancy manager, the redundancy manager sends out a command to other switches on the ring to rewrite their address table and reset the aging timer. An unmanaged switch will not be able to perform this task, and it will slow down the performance of the redundant ring. So it may take seconds instead of milliseconds for the ring to re-establish the new path. So bottom line is use all managed switches in a redundant ring. Okay, that's it, friends. Then setting of the unmanaged switches. Okay, right. See, as I mentioned earlier, these are all plug and play devices. Connect the 24 volt DC power to the switch terminal strip, connect the cable, fiber, and that's all. So some unmanaged switch has a dip switch setting for each port that can alarm if a port loses communication. So that is the unmanaged switch. Okay, now let us see the managed switch setup. Okay, it's very important actually. managed switch can be plug and play devices, but the intent of purchasing them is to take advantage of the managed feature. To start with, we need to connect the 24-volt DC power to the switch terminal strip and connect the switch via copper patch cable to our laptop. Okay. So in the laptop, I'll explain one by one. Click on the local area connection. Click on the properties. In the pull down menu, highlight on the internet protocol, TCP IP, right? So click on properties. Click on use the following IP address. Then enter 192.168.616.9 in the IP address field. Then enter 255.255.255.0 in the subnet mask field. Okay, hit OK. Then hit close. Okay, when the local area connection status box comes up, hit close. Make sure the switch is powered up and connected to your laptop's Ethernet connection. Open up our browser, then type in the address bar. What is that? 192.168.16.1, the default address of the unmanaged switch. Then click on go. Okay. Then the web-based default page for the switch should appear. So now you have the web-based page. Now we have to go to the web-based management interface and we have to start, looking for all these configure. See, basically port status. This section is to display the port status and setting. Then we have a statistics. This is to display the switch port data flow statistics. Then port control. This is to configure switch port setting. Then we have a switch setting to display the information of the switch system. Then port mirroring. This is to enable and configure port mirroring setting. Then we have a virtual LAN configuration to enable and configure VLAN setting. Then we have the IP address, of course, to set the switch IP address. Then we have SNTP to enable the network time saver, the server. And we have IP security. This is to set up the IP address, which allows user to access the switch from laptop. Okay. Then we have a RSPT, that is this enable and configure the RSTP function. This is basically a rapid rapid spanning what do you call it? Tree protocol actually. See, basically like, it's an evolution of the original spanning tree protocol. That is, we call it as a STP, right? Before, right? Yeah. So this is used in network switches to prevent loops and ensure a loop-free topology in Ethernet network. Okay. So of course, RSTP provides faster convergence than STP, meaning it can quickly adapt to the changes to the network, such as link failure or topology changes or reducing downtime or improving network reliability. All these we can make use of this, friends, RSTP. Okay. Then we have a QoS, that is quality of service basically. So again, it's a set of techniques actually used in networking to manage and prioritize data traffic, ensuring the critical application receive the necessary resources for optimal performance. Okay. Then we have a IGMP, that is, we already talked, right, last time, IGMP. So basically, IGMP snooping function is in a network switch feature that helps manage multicast traffic more efficiently. Multicast, okay. So that is the point. Basically, IGMP means Internet Group Management Protocol, okay, right. So then security manager, security manager. I think I need to tell, right? Yeah, security manager. This is to change the username and password actually. Then of course we have the configuration backup to switch section to backup the switch setting on a file to a file on your PC. Then we have a TFTP updater firmware basically. So yeah. So this TFTP utility is to update the latest firmware to the switch actually. So basically TFTP means a trivial file transfer protocol. Again, it's a simple lightweight protocol used for transferring files over a network. Okay. So that is a point. Then we have a factory default, of course, to restore the factory default setting. Then finally save configuration and to save the switch setting to EEPROM memory in the switch. And system rebooter. This section is to reboot the switch so that all changes will be enabled. Then RAID control. set up the every port's bandwidth rate and packet limitation type. So these are the some of the aspects we need to watch out for when we do this, Ethernet communication, friends. That's all I have. I hope you got some insights on both the Ethernet communication part 1 and part 2. Thanks for watching. Yeah, see you in the next video wherein we'll focus on internet, industrial internet of things. Take care. Bye-bye.